At a younger company called Summa Financial Technology. Probably been in existence about a little over a year. We make financial software. Going to talk to you about life after Terraform. More of a discussion, and that's more of a question than an answer. Or I have no answers for you, but it's kind of more of a deep dive in what would life after Terraform be like. Yeah, so Terraform, we'll start there. When I say life after Terraform, I kind of exclude the vendor-specific languages like CloudFormation, stuff like that, just because Terraform is such a great tool across clouds. So when you go past that, it's like you've already moved past CloudFormation, you're out of Terraform, you're past Terraform. It's really good at provisioning VMs. You can run Chef, Puppet, or Ansible with that and get pretty much a holistic view of the infrastructure that you're setting up with Terraform. It has really good state management. It's cloud agnostic, which is one of its biggest and greatest features. It's pretty static, so we found the best way to use it was a Git-driven model. So somehow you check it into Git, it would be reconciled with your current infrastructure, then most likely run from Git. It seemed to work really well for us. And overall, I think it's a question
about the overall context, because it's something that keeps coming up with like things that you're saying. Are you using Terraform? Is Terraform a thing in the past? Is that like life after Terraform? Is in like this is
that's the discussion, yes. I'm just laying out what Terraform is for anyone who hasn't, but yes, the discussion is going to go, what happens if, what do we do after Terraform? Or why would you look for something that's not Terraform?
Okay, cool.
Because it's overall a really great tool.
Right.
Why would you move on from it?
Maybe I asked just like a second too soon.
That's right.
I'm sorry.
What is killing you after Terraform? That's what we're going to dive into. And I think it's mostly uncharted, but it's something that we definitely want to think about. And then I'll explain some problems and why you want to think about life after Terraform. First example, your developer wants an S3 bucket. You use Terraform. How would you go about doing that? You'd most likely have, if he wanted to do it himself, he's writing some HCL most likely, right? He's going to write a little script in there, and then either is he going to hand off to your developer, Devops. Are they going to run it? Is Git going to run it? They're going to have a little bit of domain knowledge around Terraform. Databases. With Terraform, this is kind of pre-Kubernetes. You could use Terraform to pretty much provision an entire database. And then once Terraform is completed running, you most likely had a pretty good idea that that database was running and working. Because you could use Chef, Puppet, or Ansible to really provision that whole environment. Now it might be a Kubernetes operator, which is a little more complicated. How does Terraform interact with something like that? And I don't think it does very well today. Another one is like migrating node pools. If I prefer lift and shift, how would I do that in Terraform? Because Terraform doesn't really have that kind of idea of we're going to take this load and move it over to another node pool. Especially if I wanted to drain one node pool and move that workload over. That's something that Terraform is probably not going to be able to do for you. So then, do you stand up a node pool with Terraform, manually shut down and decommission your old node pool, and then fix Terraform, and then rerun it so it's in sync? So there's some complex problems. And so what I kind of laid out, or wanted to lay out, was like requirements of what Terraform does, but then what after. So I kind of plus requirements. So what do I do after Terraform, or what do I need from Terraform after I don't want to use it anymore? I kind of want a tool that's holistic, kind of like what Terraform is doing provisioning my databases on VMs. But I wanted to be able to provision databases in Kubernetes, or I wanted to be a little more domain specific to what my organization does. I wanted to dynamically update or add infrastructure. So rather than run the entire Terraform state and make sure it's in sync, maybe I just wanted to say, hey, I want an S3 bucket, and I don't have to run through that my subnet's not set up or something. Or some other developer had a subnet issue, so you couldn't run your Terraform. I want some bi-directional communication. So I want, as we set up a database, and let's say it changes over time, over 6 months, it has a little bit different properties. I kind of want that to be reflected back to a tool that was able to update itself and kind of keep that state kind of current. And I most likely wanted to use a full-featured programming language. So Terraform, one of the biggest limitations that we've all probably run into is that you have very little control on conditionals, different paths or states. And so you kind of almost need a full programming language to manage infrastructure in a new environment using like Kubernetes or something like that. And then I want auditing. So I want user auditing, I want infrastructure auditing, make sure my tagging is up to date, and that the stuff that I'm setting up is secure. And mostly, what I mean by secure, it's like you're setting up infrastructure according to our organizational policy. So you can't just stand up public nodes that are available to the internet. Essentially, I really want Cortana to establish a VPN connection with my customer. I want it to essentially almost be as easy as I just tell Cortana to do it for me. If I have some type of AI-driven system, Cortana would already know how, like what kind of VPN connections we support. Let's say we do BGP only. Like Cortana would know that domain specific, that Sumo only uses BGP VPNs, and that Cortana could ask a few more questions and then set up that VPN connection for me. So that's kind of the pie in the sky, but that's something we want to work towards. How do we make it that easy? And so here's some examples of things that I couldn't really figure out how I would do them in Terraform. We use DigiCert for our SSL certificates. What if I want to provision an SSL certificate and store that and then use that for on my Nginx ingress in Kubernetes? You could probably write a custom Terraform controller to do some of this third-party stuff. But then there's a lot of other vendors that you might want to interact with. One of our unique features that we really want is like if you stand up, we can set up multiple regions for our customers, kind of wherever they want to be in the US. We use Google Cloud currently. But when you stand up a new region that doesn't exist in our ecosystem yet, you're going to need a NAT, a cloud router, and a VPN gateway, just pretty much by default for our clients to connect to. But this is only for the first person who signs up in that region. We have more people in that region. You don't need more of those because one is sufficient. So then how would you make sure that, oh, I triggered a new region, I should make sure those are created. So that was one of our big problems. And then another one I talked about earlier is Kubernetes operators. What if we stand up an operator and it wants to request certain features from your infrastructure? I want an SSL certificate. I need a GCP service account. I need an S3 bucket or GCS bucket. We want to be able to have that interaction a little more real time than just having a developer add those to HCL or their configuration. One of our biggest things too is we use Spinnaker to do our deployments. When a new cluster comes up, we want a Spinnaker to know about it. We want to tell it how to connect to it, where the endpoints are, what's the context, and how to deploy to it. And we don't really want that to be outside of the flow. We want it to really be holistic. So when we set up our infrastructure, it's just automatically added to Spinnaker. We also wanted to use Spinnaker to deploy some certain things when we get a new cluster. So we want like Prometheus and our monitoring to automatically and our logging to automatically be deployed when these new clusters came up. Just our standard sets of tools and debug tools that, so our clusters are pretty much ready to go for any customer that we bring up. And then I talked about this earlier, the complex non-trivial upgrades. So shifting node pools and stuff. We want to maybe be able to code out a small piece of functionality that allows us to do complex upgrades of Kubernetes or even like database migrations or some type of non-trivial thing like that. And we could possibly capture metrics. So how long does it take to stand up a database? It's something, how long does it take to stand up a customer and environment? Those things that we can actually sell. We can bring those to our customer and say, we can onboard you in the next 10 minutes and here are the stats to show how we do it. So this kind of gets into the life after Terraform. This is probably the first tool I came across. I don't know if you're familiar with Spinnaker, but it's really a collection of applications, and they've really moved to this tool called Halyard. And Halyard is similar to a Kubernetes operator, where it's the control plane and deployment mechanism for Spinnaker. Pretty much the standard now. So you configure Halyard. It's a daemon that runs out there, and you essentially manipulate configuration, and then you say hal deploy apply, and then it goes out and spins up your Spinnaker environment. And then you can make tweaks to that, and then you apply it again, and it'll reset your infrastructure. And so the really neat idea here is that they have this daemon that's always listening, and so you can pretty much change configuration on the fly by talking to the daemon. Either it's gRPC, but they have a CLI that's based in that you can just say hal. One of the really nice features is when you start getting in a bigger use of Spinnaker, you want to make it more HA. You can say hal config HA, and it splits a bunch of microservices up and makes them highly available. And then you can apply them, and then you have a highly available Spinnaker. And so this is kind of the first tool that I found that had a lot of neat features on setting up infrastructure. And it actually crosses a couple of planes. The way we run is in Kubernetes, but Halyard is able to use Helm, talk to Kubernetes, and there's some other ways it can be set up. I don't think it needs Kubernetes. And so this tool is able to adapt based on its environment. You kind of configure it based on that. So this is kind of the first hint of a tool other than Terraform setting up your infrastructure. And then comes Pulumi. I think that's how you say it. Pulumi. Pulumi? Yeah. This is probably the front runner of the infrastructure, modern infrastructure setup over past Terraform. And they are a cloud native infrastructure as code, and they're fully they use a full programming language as Node, and they have some other ports, Python, some small Go support, and they essentially take care of a lot of the stuff that you want that Terraform does for you, but it allows you to extend that way further using code. So they'll handle state management, they'll handle encrypted secrets, user auditing, user logging in, who can have access. But then they have a full suite of tools that you can just interact with code to set up the environment that you really want. It's a pretty neat tool, and the idea is that you code out the domain that you want, and you leverage them as you're handling the things that you don't want to. So this is kind of a slowly slide, the next few slides from them. You use your language, you interact with their CLI and their engine, and they manage state for you. They can do it locally or within Pulumi themselves. You can send it to them, and then they store it, the paid option, enterprise option. And then they can interact with all these three providers out of the box. And so they'll add, and they're pretty young. I think they've been live for like a year or two. And so they'll add more providers, which is something you don't have to then code out. So you don't have to figure out how you interact with those providers. You just interact with Pulumi. I haven't used it yet, but they're kind of the front runners of getting away from Terraform. This is kind of more of a setup of what they can offer you. So out of the box, you're going to get the CLI, you'll get most of their libraries, and you can provision your cloud. Now, if you do the paid option, they're going to handle auth identity, config secret, state management with their S3 backend or MySQL. And so if you do the paid option, you get a lot more enhanced features. And that's something, a lot of those features were really nice. And since we didn't really want to pay for it yet, because we were still exploring, it kind of was a bummer for us. I mean, like really the config and secrets, right? I mean, we don't really run vaults yet, but you could write a vault integration or something like that on your own. But if they handle it themselves, it's kind of hard not to use them. I think most times you use something like this in terms of life after Terraform is when you're provisioning most of your infrastructure in Kubernetes or something outside of just normal VMs in the cloud, because your environment's a lot more dynamic than it used to be. And so I'm going to talk about my tool a little bit. It's not as good as the, but we didn't have to pay for it. And I'll talk about what we do a little bit and why we chose to go our own route first. So Sumo Financial Technology, we were formed in January of 2018. We're 15 people currently. 8 of us are engineers. We have a number of engineers with financial backgrounds, hence we do financial technology. Our platform is portfolio tracking and an accounting platform. So we interact with a lot of hedge funds, banks, and manage their portfolios and do some reporting on that as well. We're in pre-production, so we don't have any production clients, and we don't have a production offering yet. And we target financial institutions. So being in the financial world, the data that we deal with is very, very important to our clients and very sensitive. And so they don't even trust the cloud that well. So we have to prove to them that the way we do things is very secure, and they want complete isolation. And so we have to essentially provision them as much as they need until they feel comfortable. And so we came up with this model of kind of a hub and spoke model and we use a lot of Google Cloud networking to do this, but you get your own subnetwork, you get your own cluster, you get your own VPN, you get your own firewall rules. You're pretty much isolated minus a few connections to our hub where we do a lot of our automation. We ship our logs there, and we do our monitoring from there as well. So it's as secure as we could make it, but still offering the rapid deployment process and the automation that we want. And so far, they've been relatively happy with the level of security that we offer for them. But it's exhausting. If you set this up in the console yourself, you're probably going to spend 8 hours of clicking through and trying to remember all of the features that we turned on. And that's something that definitely could have been automated in Terraform as well. But all of our stuff runs in Kubernetes. So Terraform could have set up our networking, could have got our Kubernetes cluster up and running, but then it would have stopped there. We would need another tool to move forward. And so that's why we looked at Bloomy. That's why we wrote our own, because we wanted something that was a little more holistic and a little more domain specific to what we were doing. This is actually a layout from my tool of all the operations that need to be run for a given client setup to just get their Kubernetes cluster up and running. And we add a few Kubernetes things to set them up, namespaces, secrets. But this also does the feature that I talked about earlier, is that if you're in a new region, you need a new NAT gateway. So there's NAT gateway here. Some of this stuff essentially gets snuck into your deployment because you're in a new region, or just make sure that it's readily available for you. It's mainly VPN gateway, NAT gateway, and some routing rules for those. So why build our own? Well, it's pretty uncharted territory. There's not a lot of reference out here on how to do it. So we really wanted to learn and understand what does it take? What kind of requirements would we have out of a system now that we can move to one? So Bloomy, we have a lot more questions for Bloomy now and a lot more idea of what we want from them in an infrastructure manager. Since we're a young company, we have no tech debt. So we were able to essentially build this from the ground up with the infrastructure that we're going to be building out for our clients. So we didn't have to support any VM setups or anything. It was all Kubernetes. It was automated as possible. A lot of the things we learned in the networking and the Google Cloud setup, we could codify them as we were going along. So we learned a lot by doing that as well. And then with our tool, within a few weeks, we were able to show progress. So we code out a layer, we were able to show that we could stand up the networking and it'd be really secure and it had all the features that we want. And why not Bloomy? And one of the big reasons is that I'm a Go developer. I don't really have a lot of experience with JavaScript, and being that this infrastructure is very complex, I didn't know if I could program a full fight a language to build our infrastructure as well as build out our infrastructure. So I fought one problem rather than two. Some of the features require a subscription. That was we didn't want to pay for that. And I think there's the only ones at the time that I know of. They still might be the only ones that you guys might know more, but from the research that we did, it was, we definitely need more in the space. And then as for the Go, they say they do Go, but I joined their Slack channel, and it's kind of checking like where's their Go development at, because I was going to look to see if we could at least integrate SFT with that, and they pretty much gave up on it. They're like, yeah, it doesn't have a great experience in Go without generics, so they kind of abandoned it. So even though they say it on the website, I wouldn't recommend using it. But they don't say it. They don't recommend using it. But you, like, that's not on their website. You gotta go join their Slack channel and start poking around. So let's talk a little bit about SFT and kind of how it was built. This is an architecture diagram. It interfaces with a lot of different infrastructure. You can provision our SSL certificates, you can provision our Google Cloud infrastructure, and as well as work in Kubernetes and Spinnaker. It's a daemon and CLI and config source, so it's built very similarly to how Halyard works from a high level perspective. I really like the idea that if you have this daemon available, other things can talk to it other than just me or the CLI. As ready to go, there's 5 abstracted layers, and I think I have a slide next going over that. We have encrypted secrets using KMS and Google Cloud. Is a really trivial solution in Google Cloud to use. We're able to scope our infrastructure by client. So all of our infrastructure now is really scoped to a granular level that we define, which is really nice. So we set it up, we can manage our infrastructure at a client level. So if we had 50 clients, you could actually have multiple people working on different clients at the same time. And again, it's domain specific. So everything that you provision has a little bit of SUMA flavor in it. You can't provision public Kubernetes nodes. We essentially just turned off all the things we didn't want, or default them off, and then you can override them. And so I think that's kind of where the future is going. Like the future is that domain specific area. So this is a little UML diagram of how does it work. Let's say I want to add a VPN to my client. I talk to the server, I say, hey, I want to add a VPN, here's a bunch of configuration. It goes through a layer of parsers that essentially validate that your VPN has all the right fields to it, and that it maps to all internally to all, you depend on a VPN gateway, that it's configured correctly on that VPN gateway. So it does pretty much a deep state analysis and verification that it's going to work in your ecosystem. I think I had like 3 or 4 layers of validation to make sure that's going to work before it's inserted. And then you'll save it to configuration. So essentially your job is to interface with configuration. And that's kind of the Halyard way as well, is that you modify, change, or update configuration, and then you apply it with another command. And so once you apply it, it goes through validation again in case other things change. It'll load your configuration. It'll generate all the work that needs to be done in that on that previous slide with a list of work. That's the work that gets generated. And then it essentially runs that work through a workflow engine. And then it uses Go functions, or so you can do concurrent workloads essentially. And then while it's running, the statuses are streamed back to the user until it's complete. So some of the good things about it, we reduce our client setup time to minutes in a very complex environment, and we know it's secure, we know it's safe. We do more than GCP resource because we wrote our own and it's in code. We can pretty much interface anything we want to talk to. You can dynamically add resources yourself, or you could have other resources adding them as well. There's the automatic shared resources like VPN gateways, domain specific. And now we know what requirements for a third-party system. So when we shop around, we have a very long list of features that we would want to set up infrastructure. But not so good. I wrote it. So I shouldn't have to write something like this because, against an army of developers writing open source software, it's going to be better than what I can write. It needs a lot of features to really be a full, complete product. We're about version 1, but we don't have state management. You can't do updates or deletes because we don't have state. There were too many responsibilities that I had to write. So these are the list of the big 5 that I had to do. And realistically, the only things I care about is that I want to do my domain-specific validation. I want the code to be all about my domain. And if I want to do a custom implementation to something that they don't support, I'll be able to write that. But in terms of libraries, workflow engines, state, even a CLI gRPC server, those could all be auto-generated or used from a third party. And something like Palomi does a lot of that. So it is a solution that, maybe once we get a little more funding, we pay for. They're definitely a good option to solve a lot of those problems. So final thoughts, I want a holistic infrastructure tool like Terraform was for provisioning VMs in the cloud. I want to write domain-specific code. I don't think I've said that enough. I want it to be less static, a little more dynamic, a little more interacting with my environment. I don't want to be the only user. I want it to be simple enough that a developer can do it. And I want more players in this space and more ideas. Or even, I think there's some opportunity to even use some of Terraform's backend to support some of these features as well. Yeah, references. And I have a little demo I can show off my tool. But what do you guys think? Have I convinced you that there is a life after Terraform, or should we all stay back in our bubbles?
So something that would be really helpful for me is if you could go back to this slide where you had your requirements for like what you needed and talk about among those requirements, like how far did Terraform get towards actually providing that, or like what areas were Terraform just like unacceptable for you to be able to use that to do what you wanted to do. Sure,
yeah. In terms of like auditing and stuff, I believe they can do that pretty well. They don't have the full feature programming language, and that's going to be the biggest burn. And I just want it to be more dynamic, right? Like the state management they have is really good, but that front end is like you take it, you apply it. There can't be anything else like really listening to it.
Why do you want a full feature programming language? Like, you can't audit that. It's basically you have the right to shoot yourself in the foot, right? And if you're trying to make a tool that has constraints around it, like the constraints are a gift, they're not a limit.
Sure.
And I think like having a full feature programming language means that you can just put whatever you want in there. And so there's no way to say state looks like this, because you could have had a resource that defines state and then you made up your own thing that just went and modified that. Like from a theory perspective,
Sure.
If you want to describe state, you can't be Turing complete. Like it doesn't work. So,
sure.
Like, do you want declarative or imperative? I think that's really the fundamental.
Well, can you give us an example of where a full-featured programming language with the tool that you end up building allowed you to do something that you just wouldn't have even attempted before, or that like provided huge value that you wouldn't have captured otherwise?
I think you said it. I think you said that Terraform stopped at Kubernetes, right? But only did the infrastructure. It didn't take you to the next level, right? Is that what?
That's kind of where, yes. I mean, if you look at the Kubernetes plugin, I mean, you can create some namespaces.
I mean, the thing I would actually say Terraform falls over is bidirectional. Like, you can say, go do this, and you have no idea afterwards what it looks like now.
Right.
You know, you can set up an auto-scaling group with, say, I want 10 things in it. If it auto-scaled to 50, the next time Terraform runs, you have 10 again, which is terrible. So
at the same time, that helps compliance, right? Like if you create a security group, it says open up port 80, and I go and edit it to say 8081, right? Like,
right.
Like,
Well, that's what I'm saying, but it's not bidirectional, so it doesn't report that. Like, it doesn't report that it closed down at 8081. It just doesn't.
So all I'm saying is like, if somebody like in your corporation or whatever were to go, they can edit like a manual edit outside of your tool. Terraform can detect and correct that. So,
It will correct it.
What's that?
It will correct it. It doesn't detect it. Like, it's
Well,
a
it will correct it after the.
I think the problem is that you don't know that it corrected it until later you see it wasn't wrong. If there's not a piece of data.
Oh, okay, so you can get.
Hey, I did this, like,
Yeah.
oh, I detected that 80 got changed to 8081. I'm changing it back now to 80, which is what it should be. So you don't have that feedback from the tool to be like, oh crap, I need to go find someone and let them know they shouldn't do that.
But maybe you get away from like the holistic state then. Like you have more dynamic state, and I don't know how you do something like that, but you don't trust state as much.
Well, you want sub-states.
Yeah.
But I really think the communication of Terraform, having worked on a project that's after Terraform, is the bidirectional communication piece. So, and there are other projects in the space besides Pollution.
Yeah, I bet there are. Do you know any? Or like, use them?
Lyra, Lyra, be the other one that it's gonna launch at KubeCon next week. For 2 weeks.
Okay.
So
It's available again.
Lumi is also a CNCF project.
Yeah,
too, as well.
And like, I'll say for Lyra, it's developed at Puppet. I don't work there anymore, but it's developed there. They partnered with Lumi for a while to kind of look at like what they were doing and how they were doing it, and then decided to part ways. But the other thing that's really interesting about Lyra is it can run anything Terraform can do, it can also do and more, because it loads in the Terraform loaders. So like you already have a foundation of the ecosystem, and then you can go do more, which is kind of cool.
That's kind of where I think my tool is going. Or like, as I was writing this, I'm like, damn, I should just back this with Terraform and solve a lot of my problems.
Yeah.
Just a question, I'm kind of new to Devops, but not recently there. HashiCorp also has this thing called Nomad. Did you look at Nomad at all?
I have not looked at Nomad.
They have some real like vague documentation. If you go like Nomad page about Kubernetes in particular, right, where it says, you know, we have a lot of overlapping concerns here and not real clear what the value prop is. I was just wondering if maybe we might knock out
I really think this has come out, like this problem, it really is like shown its face in like the last 2 years. And so like, even with like Kubernetes operators, like I want my infrastructure to work with operators somehow, but there's not really a standard. Nobody's really like figured it out yet. And so that's where like a lot of the unchartedness comes from, is that it's just not, it's not mature enough yet, I think. Like my tool should like provision some type of operator and then, you know, stay in constant communication with it, because that operator is way more dynamic and it's going to be managing your infrastructure a lot more fine-tuned, I think, in Kubernetes.
I don't have an answer, but we ran into the same general problem was, great, we have Kubernetes, and now what? Because Terraform just can't do what we needed to do, not in that ecosystem. So we essentially had to make a choice of a handoff, and we're not even remotely done with this project, but we're flipping the cluster to be more GitOps. So we have Terraform provision the cluster, provision our core operator, which then takes over. And that's the best we were able to come up with for now.
Yeah, I think that's where like, it's not holistic anymore. I like the holistic.
No, it's
world,
not,
and
yeah, so.
I want to back up it somehow.
But there's also a scale issue there, right? Eventually you can't keep the complexity of the infrastructure and the application and the data domain all in your head at once, and so you want to be able to split it.
Yeah.
Like right now, when you're small at 8 people, you want holistic, but in the real, like, when you scale out, you don't want holistic. You actually want to be able to hold your part of the domain in your mind, and that's where like Terraform is really good at its stopping point. And then you want like application deployment, that's a different layer, and you want data layer separate. And it's all about scale and like how are you operating within your organization. Like it's a human problem more than a software problem in a lot of ways, because it's all how you slice and dice it.
When I mean holistic too, it also means that like, let's say a provision operator, right? Like I can ask that operator and trust that it knows how to communicate with me effectively to say that it's doing its job effectively. And so that my tool then can report back to me that yes, as far as I know, everything is right as the world sits. So it's more of a, it's not going to do a lot of operator work, but it at least can manage that, or yeah, be its manager, I guess, an operator manager.
Based on my conversations with people that use a lot of the Hashi stack stuff, this kind of gets to what you were saying as far as like where Nomad fits in. Hashi sees this as being like Terraform sets up the base infrastructure, and then it's done. It doesn't care anymore. And then like on top of that, Nomad is managing like the applications that are running on the infrastructure, and then the data is managed by console. And that feeds into Nomad, and it also feeds into Terraform again. If you're going to do a re-Terraform, it can be based on the So that's where they see as like the bidirectional, is like something that's happening gets like pulled into console, and then if you re-terraform, it pulls stuff out of console to find like what's going on. Like Terraform doesn't have that. There's no concept in Terraform of that like state and bidirectionality, because if you're, of course, what Hashi wants you to do is adopt the entire Hashi like stack, right? And use all their things. So they build these pieces to be like very interreliant. But then if you are basically really like smart at building Terraform things, but you're not using the whole stack, then you really like, it really kills you when you don't have the features, the like holistic vision, because Hashi sees the holistic vision as being our entire product line, not any of the one pieces.
So I got a question here. Now, most people use, Terraform, provision or set it and forget it. Why don't they run it more frequently? Why don't they have a system set up to run it constantly and always keep the state? Because the difference between state management, is not, it's just like just knowing the state. So, but there's also enforcing the state. So, by using tools like that, constantly applying it to an environment, that way if it's ever out of state, it immediately gets corrected, not necessarily a number of hours or days or years later.
Have you used Terraform? Just secretly behind the scenes decided to automatically resync. That would be terrifying.
I was gonna say that's.
Yes and no.
It depends on what you allow externalities to do.
Yeah, like I've had various infrastructures, one that I didn't use anything like Terraform. We enforced state, and if a node got brought up and somebody was just applying changes, it would be very quickly shot. Just apply stone it and re-kick it as the type of node it expected before. And that's the system kind of enforcing, provisioning, expectation of clusters. But then the state problem is usually managed through things like configuration management internally on hosts. But no one likes talking about those.
Well, the other issue is like, none of these are event-based. And I think that's actually, what you actually want is event-based streaming for rectification. Like, that's how you reconcile your state management differences. And as far as I know, there is not a tool in this space that does event streaming and reacts to it properly. And it's only because it's a really fucking hard.
So you're telling me that you
standardized.
Yeah, well, like we definitely have some prototypes of it at Mopic where it was like streaming events back and making changes based on events point. But it's like, that's great for 2 servers. Now do that for 50,000. And, or, resources when you go to cloud native, like your RDS does this, what do you do? Panic, like it's really hard. So,
Yeah, when we run into issue like GKE will constantly update itself, and then it's out of state, so dealing with stuff like that as well. Yeah, I don't even know how you would event something like that. You'd have to have something watching GKE, like, oh, your cluster upgraded, notify my administration.
I'm not that familiar, but I think people that work with do that. They're looking at drift, confirmation, kind of does that. And they're not really interested in syncing the state because sometimes things happen. Like on your slide above, develop one S3 bucket. Some dude goes in there, and I think you got a best case scenario where you say, hey, they create some HCL and applied it. Well, in the real world, they're going to go to like the Google Cloud Console or AWS Console. They're going to create an S3 bucket if they have permissions to. And good luck if you got HCL for it. So what I've seen is people like, hey, they're observing that the state has changed. And that's not necessarily a bad thing because it's for a reason. Maybe it's in response to an outage, or maybe they're testing something out, and then and then notify something. And I think they may do some Lambda invocation based upon those events. I'm not that familiar with it.
you can, but you have to set all that up. Like,
Yeah, it's all tune data.
it's all around where do you want control and how do you want it. And
Yeah, I think I think that team, they don't really want, they're like, like, we kind of trust you guys. If you want to change your infrastructure, we get it. We'll stick it up eventually.
right, but then you have no state source of what it's supposed to look like. I mean, like, there's a trade-off there every way you look at it. It's not the other than wrong.
We should probably wrap it up here.
Yeah, it's just super interesting. Like, I mean,
Yeah,
fascinating.
I just want to make sure that, we don't, stay too long. But also I wanted to thank everyone. I want to thank Nick for this great presentation on these after Terraform tools. I'm sure we're gonna still talk about it once we're.
I hope they talk about it. That's the idea.
Don't
talk about it more.
He'll be hiring for his new startup soon.
There we go. For, like letting us see into the world of PowerShell dashboarding. You know, applause for Alex here, for bringing. And very interesting, noble effort. So again, if teaching or if somebody's interested in it, please talk to him. Otherwise, I'll have his contact information. He's also part of the meetup, so you can reach out to him directly there. All right, then we'll just wrap up. So thank you so much again. I already have next month's set up in Meetup calendar. I do need speakers, so if there's something that you've been wanting to talk about, maybe just something cool you've been doing at work, like, hey, I just finally figured out Grafana. It's like, all right, cool, come on up, let's talk about it. Or you figured out some new plugin, or you're Mike and you're playing around Circle CI and you want to talk about what you do. All these things are options. And it doesn't have to be something that's intimidating in terms of like, you're expecting this or this. Like, we just come in and we talk. And we talk as friends, and we live, and we learn, and we eat vast amounts of pizza. So great. All right, thank you again, everyone. Have a good evening.
I just